Hello and welcome to another mini lesson about propositional logic. In this lesson we're going to talk more about how to prove things using truth tables, and specifically we're going to talk about proving what type of formula a given formula is using a truth table. So we have here three basic types of formulas: a contingency, a tautology, and a contradiction. Up until now we've basically looked at contingencies, which are statements that are true in some models and false in others. So for example, P and Q is a contingency because when we construct all the possible models, right, where they're both true, one is true, the other's false, or where they're both false, there are some cases where P and Q is true and some cases where it's false, which means that P and Q is a contingency. This is most formulas are going to be contingencies in the end. Our first special type is a tautology, which is a type of statement which has to be true in all models. So for example, the statement P or not P is a tautology. So we can construct two possible models where P is either true or false, right? There's only two models because we only have one basic statement here, right? Either P is true or P is false. The not P is either false or true. And so in both cases, whether or not P is true or false, P or not P is true. I mean, this is, you can think of this in human language too, in natural languages, as an example like John is tall or John is not tall, right? Obviously, one of those is going to be true. Tautologies are sort of vacuously, emptily true, right? It doesn't mean that much that they're true, but they're always true in any possible world. All right. And then we have a contradiction, which is the opposite of a tautology. A contradiction is a statement that is false in all models. So for example, the statement P and not P is false in all models. So we have two possible models here. Either P is true or it is false. This means that not P is either false or true, and so there's no case where they're both true, and so it always has to be false. So it's a contradiction. So we've already seen three examples of how you can prove what type of formula a given formula is, but we're just going to walk through one that we haven't seen in order to prove what type of formula this is. So we have here a statement, if P, then P and Q is true. And this has to be a tautology. Or P or Q, sorry. If P, then P or Q has to be true. This is a tautology. So either we have four possible models, right? These are our four possible models. So we're just going to start filling out this truth table. So P or Q is the first thing we're going to do. P or Q is true in this case, in this case, in this case, and not in this case, right? And now we have to do if P, then P or Q. So remember, this is only false if we know that P is true and we see that P or Q is false, right? Other than that, it's going to be true, which means our bottom two, where P is false, are going to be true automatically, right? Now we have to look at the cases where P is true and see if P or Q is true. And in both cases it's true. So we have true all the way down, which means this is a tautology. Ta-da! So this is how you prove what type of formula a given formula is, and also gives you a definition of tautology and contradiction and contingency.